Cement is the main ingredient of the concrete. It reacts with the water and make it a hardened paste. It also binds all the ingredient together to make it a homogeneous paste. So in order to get the right kind of concrete, we need to understand the properties of cement. In this video, I will discuss what is the properties of the cements and accordingly how we can select the cement for the better concrete or the better strength of the concrete. So stay tuned until the end to get the full information about the properties of the cement. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. So let's start with what is the properties of cement. What is the main things we need to know about the cement so that we are well aware whenever we are selecting the cement for the concrete itself in order to get the right kind of concrete. The first thing what we need to know, that is fineness of cement. It is very much essential that we need to understand what is the fineness of cement. This is the properties of cement. Let's see what is called fineness. Fineness is the particle size of cement. It is measured by the surface area of the cement particles per units. So it is how much it is the fine particles and it is a surface area of the cement. How it is affects? It affects the rate of hydration, strength development and workability of the concrete. So it is responsible for the rate of hydration. So if we need the early gain or early strength or the late strength, so we need to play on the fineness of the cement. And accordingly, the for 33 grade, 43 grade and 53 grade, this has all the different fineness modulus so that the rate of hydration can be changed and the strength development also is a factor for this fineness. So first things we need to know what is the fineness of the cement. This is the one of the most criteria for the selecting of the cement. First, we need to know the what is the fineness of the cement. So this is fineness of cement. The next criteria or next part is soundness of cement. What is soundness of cement? Soundness is the ability of cement to retain its volume after setting without delayed expansion. If it is expand after the setting, that means it is not the sound concrete, it is cement, it is the unsound cement. And if it is volume is increased, that means there will be crack, there will be a void, we will not get that concrete of strength and the durability. So we need to check the soundness also for the cement. It is the very essential property, same as the fineness, soundness of the cement also we need to understand to get the proper kind of flavor of the concrete. It is affect the durability of concrete, especially in structure subject to alternative wetting and drying. So it is a long-term effect. If concrete is cement is unsound, then the volume will expand, there will crack, voids will be a pair, and it will affect the durability. So we need to find out the what is our fineness criteria, and then we need to ensuring that our cement is the sound cement, it is not the unsound cement. So how it will measure all this fineness, soundness? In the next video, I will discuss about how to measure all these fineness cements and what is the value to be is there in the IS code. So everything I will discuss in the next video about what will be the value and how it can be tested, the fineness and the soundness. Now, in this case, in this video only, what is the properties we need to understand about the cement. The first thing was fineness, then this is a soundness. After that, it is coming in a compressive strength of the cement. It is same as the concrete. What will be the compressive strength in 28 days? The compressive strength is the ability to cement to resist axial loads applied gradually. So same as cement, it is also as per IS 4031, we need to check the strength, compressive strength, and accordingly the grade of cement is defined, such as 33, 43 and 53 as OPC is mentioned as per 269. IS 269 is already mentioning the grade. So compressive strength also is very much essential or very much important factor for the cement. In order to get the right kind of concrete, we need to select the cement also. If we need only the finishing things or some the lean concrete, maybe we can go for OPC for 33. But if it is required strength development and the structural member, then we'll go for the OPC 453. So higher grade of concrete gives the higher strength of the concrete. So accordingly, what is our requirement? We should choose the cement according to the compressive strength of cement. So fineness, soundness, compressive strength. Then it is coming heat of hydration. What is heat of hydration? Heat of hydration is the heat evolved when cement react with the water during the setting and hardening process. What is happening? Whenever we are adding water, it's react with the cement particles like CaO, SiO2, Al2O3, is everything. And whenever this is reacting with this, the heat is generating, and this heat is called the heat of hydration. It is a very much crucial things for strength gaining and durability. So we need to know what is the heat of hydration and how to calculate the heat of hydration. It is mentioning in the as per IS. In the next video I'll discuss how it is influence the temperature rise in concrete, critical for massive structure. Now if there is a heat of hydration is more, the concrete core itself will be temperature will be more, and if the environmental temperature is less, so there is difference in the temperature, so heat will be transferred from that core to the environment, and whenever it will be, and it will making a path along the concrete, and it will in the cracks. So heat of hydration, if it is more, then the crack generation can be happen. So it need to required to know what is the heat of hydration of that cement, and accordingly we need to monitor the temperature and control the temperature. If it is a massive mass concrete, it's a higher depth of the concrete is more, then heat of hydration is always the critical factor. We need to understand, and we need to check the temperature in the core or in the surface, and accordingly we need to plan the design mix, and we need to control the temperature itself at the site. So that why heat of hydration is a very important and crucial factor for the cement properties. The next is a setting time of cement. All we know that setting time is the time elapsed between the addition of water on cement and the development of certain degree of hardness. And there are two types of setting time. That is, one is initial setting time, another is final setting time. But what is setting time? Whenever we are adding the water to the cement and a certain degree of hardness it is achieving, that is called the setting time. Now let's see what is the two types of setting time, that is initial and the final. Initial setting time, what's called the initial setting time of cement, is the time elapsed between the moment water is added to the cement and the point where the paste start losing its plasticity and begin to set. So whenever we adding water, the cement paste become plastic, and when it start losing that plasticity, it is called the initial setting time. That's why it is very much important to know the initial setting time, because within the initial setting time we need to pour the concrete. If whenever it is just losing to plasticity and beginning to set, that time pouring the concrete is not advisable, because it will not gain the strength and durability. So that's why we need to know the initial setting time, so that accordingly we can plan our concrete. And then what is the final setting time? The final setting time of cement is the time elapsed between the moment water is added to the cement and the point where the cement paste has completely lost its plasticity and has attained sufficient hardness to resist a certain amount of pressure without indenting, sorry. So this is the final setting time when it is completely lose the plasticity and certain amount of hardness is achieved. Why? We need to start the curing that time. That's why you need to know that where is the final setting time, because after that if we're not doing the curing, then there will be chances of moisture loss, and if it is a moisture loss, strength and durability cannot be achieved. So the setting time is very crucial, initial setting time as well as the final setting time. How the setting time influence on the concrete? Influence construction process, particularly formwork removal. So that's why the formwork removal is possible when a certain degree of strength is developed into the concrete. So how we can know there's a setting time? So that's why we can remove the formwork and we can start the next activity or next sequence of pouring. So that's why with the initial setting time as well as the final setting time is very much important. The next is chemical equivalent. So chemical requirements, in every cement we know that the C3S, C2S, Al2, C4AF, that all the four criteria is there, but according to the requirement that can be changes slightly, and that can be play a very crucial role to selecting or making the cement. So how it can be? So it is in IS 269-215 in the table 2, chemical requirements of a Portland cement is mentioning. See, there is 5 grade of cement as we earlier discussed about different grades of cement. If you're not watching that video, please check in the link and in the description box, and then you will understand about difference between 33, 43 and 40s. See, here we're saying ratio of percentage of lime to percentage of silica among alumina and iron oxide when calculated by the formula. OPC 43, what will be the ratio? 0.66 to 1.02. OPC 43, same. 43 is 0.8 to 1.02. For 53 is 0.8 to 1.0. So again, the second is ratio of percentage of alumina to that of iron oxide. Minimum this should be there. And then insoluble residue per percentage by max. This is maximum the percentage. Then magnesium percentage by max. Then total sulfur content calculated as sulfuric acids percentage by max. Loss of ignition percentage by max. Chloride content percentage by max, and alkali content. So this table is very, very much essential. You should know as a civil engineer when you are starting your journey in a project or a construction site. This table has to be memorized. No other things, that what will be the chemical requirements. If we're not understanding the chemical requirement, we cannot select the right kind of cement for the right kind of the concrete. So accordingly, we need to select, and we need to know the chemical composition, because this everything has their own requirement in the cement paste or in the concrete. So whenever we need early grain stain, whenever with the rapid hardening, whenever with the what kind of different types of concrete, then different kind of cement we need to select, and according to the characteristics of the chemical composition, we need to select what is the our right kind of cement for the right kind of the concrete. So this chemical composition also we need to carefully understand what, and it needs to memorize, so that we can select the right kind of cement for the right kind of concrete. The next is false set. What is false set? False set in cement refers to the premature hardening or stiffening of the cement paste without the development of normal setting characteristics. That means it is not the normal setting. It is the premature hardening or stiffening. So that it is not giving the initial setting or the final setting, nothing, but it becomes stiff. And if it is stiff, we cannot pour the concrete or we cannot do the concrete. So it becomes very difficult to use that concrete. So these things is called false set. It is not initial, not the final setting, but it is appearing it's the hardened, or it is set, but it's not as per the heat of hydration and the chemical reaction is not happening, but still it is become stiff. So this false set of cement is a very critical. We need to check whether there is any false set or not. So it is important to note that false set is different from the initial setting and the final setting, as I discussed. Then how this can be happen? This contaminants, presence of certain contaminants such as gypsum, calcite, or high amounts of alkalis can induce false set. So we need to check that all these impurities or the contaminants is there or not in the cement, so that whenever we are doing the concrete, so there is a chances of the false set. And if it is false set, our concrete is totally waste. And what another reason for the false set is the improper storage. Exposure of cement to moisture during storage can also contribute to the false set. So that's why the storage of cement is very essential. It should not be taken the moisture from the environment. If it is happening like this, it is there with a false set, and cement lumps can be have developed, and cement can be not used, and it can be rejected. So that's why we need to check the cement storage itself. So these are the main properties of the cement. Again, what is that is a fineness of cement, then soundness of cement, then compressive strength of cement, then heat of hydration of cement, then setting time of cement, then chemical requirements and false set. So these are all the things that we need to check whenever we are selecting the cement, and we need to know what is the cement properties. And as per IS 269-2015, it is completely written what is the physical requirement and what is the chemical requirement. So I hope I have covered everything about what is the properties of cement. And if you find it is useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comments so that from your comments, everybody can be benefited. And if you want to know anything more about quality control and constructions procedure, please let me know. I will come here with more content like this. Thank you. Thank you very much for watching me.